Okay. Next, Katie. There we go. All right. So I'll just explain real quick who I am. I started my first consulting company as a wee lad in my mid 20s in 1994, and then people who know who Jimbo is joined me in 1997. Then I founded Enterprise DB with Philip Merrick as the chairman of the board in 2004. Philip is the CEO and co-founder of PGEdge with myself. Hello, hello. Oh, that's it. I gotta speak right into the mic. Yeah. So 2004, founded Enterprise DB with Philip Merrick as the chairman of the board there. Philip is also the CEO and co-founder of PGEdge with me, and here today. 2018, we sold OpenSCG to AWS, and that kind of formed the core of their Postgres dweebs. And I played principal product manager there for about 2.5 years of torture. 2021, I started OSCG Partners, which is kind of a consulting thing, and then in mid-2021, 2022, joined forces with Philip, and in March of 2023, we're announcing a product, which is more or less a couple days ago. Hello? 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 Oh, I could talk into it like that. Ah, you see, this is tricky. I wanted the little fancy one that no, I'm kidding. I can learn to talk into the mic. Okay. So Philip and I, this is a picture of a couple old guys who used to be much younger, but this is us having a toast for starting the company. Go ahead, the next one. This is, I'm not going to really talk much about this slide, but this is why Postgres, and it's not just because of the bow tie and Bruce, but that's what he thinks. But Postgres is really good. Everybody's already convinced of that, so I'm not going to spend a lot of time on that. In fact, that's it. Now, why logical replication? Logical replication, I mean, from my perspective, the biggest reason why logical replication is because you need to be doing logical replication in order to do active-active asynchronous with conflict resolution and avoidance, if I could say all those things. So some of the side effects of logical replication is you get near zero downtime upgrades between versions. It's kind of a nice side effect. It follows a pub-sub model. It's transactional, so you don't see anything on the other servers. It may be asynchronous, so it may be delayed a little bit. Hopefully only a few hundred milliseconds, but you will at least see it transactionally consistent across the systems at any given time. You can do, with logical replication in general, you don't have to do the entire Postgres cluster, right? If your Postgres cluster is running multiple databases, you can do, you can say, I only want to do one of those databases and not the other one, or whatever. And then even within a database, you have even more flexibility in that you can do row level filtering. In our stuff, we've added it so that you can do filtering of partitions, things like that. Also, you've got some flexibility with these tables so that the way we do our logical replication with active-active, you've got some flexibility in that they're loosely coupled. So we try to make them tightly integrated, but keep them loosely coupled so crazy things that happen on one server don't necessarily, or they don't negatively affect the other servers. Logical decoding, I'm not going to talk too much about it, but that's just the way Postgres does logical replication. It kind of, you take the physical write-ahead log and you turn it into insert updates and deletes, is the way I think about that. It's probably a little more complicated than that, but I think that's pretty much it. And the cool thing is, and this is sort of what I was talking about, is that the nice thing is that the individual databases, when you're doing logical replication in general, they're quite loosely coupled so that you're really just sending over the inserts, updates, and deletes. That means you're not, like one of them's vacuuming, it's not necessarily creating a bunch of traffic for the other one. So there are some advantages of logical replication. I don't mention it here, but there are some disadvantages. I think of the primary disadvantages of if you're doing a massive update and you decide you're going to do it on one node in the middle of the day, which is usually a bad idea anyway, but let's say you did that, you have one SQL statement that updates 1,000,000 rows. You're going to send over, if you do that blindly without some advanced features that we're introducing, if you do that blindly, you would send over 1,000,000 updates over the wire, and that could slow you down in the middle of the day, believe me. So logical replication, lots of benefits that I had there. That one negative that I told you there is something that we work on and we address a little bit, but you have to be careful of that in general when using logical replication rather than physical. That's one thing that physical kind of does better. History of pgLogical and BDR. So the Spock extension that I'm going to talk about, Spock extension I'm going to talk about comes from two things. So the pgLogical extension that Simon and his second quadrant cohorts wrote somewhere in the Postgres 9.5 area is the basis for what we're doing. But they also produced something for Postgres 9.6 called BDR. So this was really, BDR is kind of pgLogical 1. pgLogical 2, which is what it's out there in open source right now, they stripped out some of the features of BDR to make it more palatable to the community. And then, to the credit of Simon and Second Quadrant and EDB later on, even a little bit, a lot of the core features of pgLogical over the last 5 or 6 years have been added into core Postgres. So it's a success story, and we're glad to build on that stuff as a pretty solid foundation for what we're doing. On the negative side, the pgLogical extension has been in maintenance mode for at least 4+ years. No major new features, slow to come to newer versions, and not really fixing stuff unless somebody submits a patch and it's really obvious that that's the right thing to do is to apply that patch. But they've got in their defense, they've got a commercial solution at Second Quadrant and then at Enterprise DB. That is a proprietary multi-active solution that if you like proprietary and vendor lock-in, then you're welcome to use that. pgLogical, I thought that said Spock will not compete with their proprietary solution. Spock will compete with their proprietary solution, but pgLogical will not for obvious reasons. And I think I talked about the last 3 points. Okay, so what does Spock do? So Spock is really, you can think of it as either Sloaney 3 or pgLogical 3, because it's kind of both of those. What we're doing is taking pgLogical 2, which is open source, but we're adding as many features as we can, as quickly as possible, while still keeping it, well, actually making it more stable and more robust and performant. So what we're doing is supporting asynchronous multi-active replication. We've got a cool feature that I'll talk more about called conflict-free delta apply columns. Think of it like CRDTs, conflict-free, CFRDTs, or whatever that is, conflict-free data types, but not requiring a special data type to do it. So that's a la Jan doing that. But we also offer better management and monitoring, stats integration, performance stability, network stress testing, which is a bunch of stuff we're doing. Done a bunch of work to make sure that we handle replication well of partition tables, which Postgres started doing recently, doing better in that area in the last release or two. And then we got some cute features around PII and different things you can do. So we try to do, for use cases and for what people think of, the replication of partition tables, important to be able to do that stuff for kind of what people want to do with geosharding. We have some pretty simple, but we think clever stuff for doing with PII columns and making sure that we know what database the country is in, and you can null those out so that they don't go out of country, and you can use it. You can use it in production that way. Some people will use it in a for test databases that they want to just automatically in the replicas not replicate any of the PII data. So there's different clever things you can do with that. Use cases, talked a bit about these, upgrading between major versions of Postgres, full or selective replication, partition tables. You can do tiered replications with pgLogical in general in terms of not every bit of data is configurable, so not every bit of data has to go to every other machine, right? You can, do logical replication to one other machine that you're using mostly as read-only, if at all, and then that thing will forward and get all the updates from everything else. So there's a lot of flexibility in how you can use logical replication. There's also a lot of ways to shoot yourself in the foot, so you got to be careful with this stuff. But it's very powerful. What we're trying to do from an extension and from a product standpoint is make that power more accessible, so that people can do more use cases in Postgres that are active-active, because everybody kind of wants to do that, but everybody's afraid of it. So we're, with the rock-solid Postgres at each node, we're trying to make that more achievable. How are we licensed? We are licensed with a community license. Now, what does that mean? That means that Spock is open in PG license. Our license allows unlimited production use. It's essentially the same as the Confluent community license. For those that don't know what the heck that is, Confluent is the commercial company behind Kafka. And that's become a pretty popular license. It's pretty simple. It pretty much says, do whatever you like with this, but you can't, it's not just AWS. I was just goofing there when I said sorry, AWS. But the only thing about the community license says that you can't offer it as a service that competes with our stuff. So a customer can use it in production, but a competitor would have to talk to us before they would run that in production. So we think that's a pretty good compromise that allows us to hopefully form a business and a thriving business around all of this, an ecosystem, and yet still have all the benefits of open source for the end users. So we don't call it open source, certainly not with a capital O and S. I personally believe you have all the benefits of open source without some of the drawbacks that a small company might have if they created a nice product, and we're certainly trying to do that. Conflict resolution. What does that mean? Basically, I'm going to show in the next slide or two how you create, sort of, just so everybody's kind of on the same page of how it is that you can be, sort of transactionally consistent on each node, yet asynchronously you can replicate so that you're even transactionally consistent, but you, what happens, if you actually do two transactions at the exact same time, especially when you start one before the other and then end the other one before the first one, right? You get into weird stuff. So I'll try to explain that a little bit. But the core for what we call a conflict, there's a couple things. This is kind of important at the bottom here, in that Spock is optimized for mostly non-conflicting workloads. So if you create a workload where you're constantly trying to create conflicts on every single transaction, no matter what we do, it's like that won't work well asynchronously across regions, right? So you got to have a workload that you can reasonably partition the users, so the West Coast users go to this one, the East Coast users go to this one, and everybody in Europe goes to that one. And then you're only actually, and everybody can see each other's data that you choose to share. So something along those lines. But fundamentally, if you think of the resolutions that you can do, you can either say, this node always wins, like this, let's just keep it simple, there's two nodes. If there's a tie, this node always wins, or that node always wins, or whoever committed last wins, or whoever committed first wins, right? You can kind of do some combination of those things. But if there is a conflict, you can choose which one of these you want to default. And we make sure in our solution that we create a conflicts table And in that conflicts table, so that you can still see it in a table, you don't have to search through some Postgres logs somewhere, but you can see where the conflicts were. You can kind of see it on in the metadata tables, the system tables that we create, and you can see it in our little our dashboard thing that we do. That's probably enough for that. So this is an example of conflict resolution. And first update wins. And so this is an example where I don't want to go into this too much, but what you're doing is you're starting an explicit transaction here, right? So you're on node 1, and you're updating a table called T1, and you're setting the column called D to hi or hello, so where ID is 1. So you got a very specific record by its primary key, and you started a transaction and you updated it. So you haven't committed it yet on this node. So you've done something that you're not supposed to do. You went to lunch between when you started your transaction and when you finished it. So your application generally shouldn't do that. But if these transactions are more or less happening at the same time, it can definitely happen that, especially if you do it on purpose, like in this example, that we started another transaction that's updating the same row and setting it to a different value, and then we're committing it. So by the time this transaction gets over here and goes to commit, this row has already changed to something else. So you're actually, whoever wins this, you're either gonna, the column D is either gonna say hi or bye, right? So you had a conflict, and you gotta pick who the winner is here. So in a first update wins, in this case, node 1 would win, and you would be left with hi. Usually people update to last update wins, and you would want node 2 to win, but you can configure it. You can configure it this way. Conflict avoidance. So this is kind of a cool thing that mostly Jan came up with, but then when I realized it was a good idea, I'm going to try to take some credit for it. Unless people don't like it, then I'll blame Jan. So logical multi-master replication can get itself into trouble on running sums. And by a running sum, think of a warehouse running total for how much product XYZ you have in that warehouse. And that on that summary warehouse record, there's a running total of everything that's there that's constantly being updated. But if you think of an example like a PGBench, there's, well, PGBench is bank tellers and not warehouses, but same idea. The neat thing is that without doing either conflict-free data types, which is a proprietary thing, you need special data types, and I really challenge somebody to explain what you really do in those things. But what we do here is, so without this kind of solution, if you were to run a PGBench on both nodes and you run it full blast, you end up with both nodes consistent, but they both have the wrong answer. And that's, that's good that they're consistent, but it's bad that they give you the wrong answer. So for something like the TPCC benchmark or the TPCB, as in PGBench, you need to do something for this problem. And what we've come up with is a way to do this without requiring any special data types, and we can do it on any of the traditional Postgres numeric data types, like number, numeric, float, double precision, 2, 4, 6, 8 bit integers or byte integers. This is Jan, handsome young or old man. So this particular feature is an area where, if you think of Spock, we are community licensed on Spock. So that means it's like, it'll, even if the core wanted it, which they're not really into exactly what we're doing, but even if they wanted it, they couldn't take Spock. However, this cute feature that we're doing requires a small patch to Postgres. We're making sure that that patch is kind of separated out. That patch is Postgres licensed already, so it's pretty simple. We hope to work with the community and get that into PG16. As I said, I've talked to a few community members over there, so we're hoping that, but there's no guarantee that it'll go in the community, but we think it's pretty simple and it's pretty applicable to several use cases. So all it does is you're able to tell it which of your values in your tables by doing an alter column that you need to log the old value. So when it does the write-ahead log for these kind of rows, and it's writing out an update for these kind of rows, it automatically writes the old value and the new value in the write-ahead log rather than just the new value, so that the delta of the two values can be computed, and it always applies the delta to the sum. And that little trick makes everything work much better for the most common type of conflicts that you have in this kind of system. Yes? Oh, you switched on me? I think I pretty much said this before you switched. Before the new values, the delta is created. Yeah, I said this before you switched. Conflict avoidance. Now this is the tricky one that Bruce would have his little pointer and he'd be pointing in red there and stuff like that. So I don't have one of those fancy pointers. So I'll try my best to make it clear. So in this one, this is a running sum. So the column's bal as in balance, right? So think of this as you did the person started with a balance of 300, right? And the application did a calculation of the running sum, and it just did a set balance as 310. So this transaction actually, they deposited $10 in their account, and it committed. This transaction at the same time, when it started that transaction, right, I didn't see this one, so they deposited $5 in their account in that transaction. And again, you're just setting the balance explicitly. You could either set these as, bal plus 5 or bal plus 10. It would work fine that way. Or you can have done that math in your application. But by calculating, that's a $10 deposit. This is a $5 deposit. When you're done, the answer can't either be 310 or 305. The answer has to be 315, right? You've got to get your $5 deposit and your $10 deposit. So conflict avoidance is about, and this works really well without special data types with this little patch that we've created, which is pretty generic and simple, and it allows you to kind of tell it that this kind of column is going on, and you get the right answer, and you avoid the conflict rather than having to choose one or the other. What's next? I always like to put other vendors on the hot seat when they show me stuff, saying, tell me what you're working on next, because that's sort of a way of saying, what's your biggest weaknesses right now. So the primary thing that we're just announcing that we're in beta right now, and hoping to go into production in somewhere in the at least 4 months, at most 7 or so. But so later this year, we want to get into production, and what we feel we need to have that's not frankly done perfectly right now, but we know what the weaknesses are, and we're working on them as we're starting up with our test periods and people seeing if this is useful to them. Is that we can handle 2 nodes, 3 nodes, even 5 nodes. We can handle intermittent outages of those nodes, right? So you get the ultra high availability thing. But what's challenging in logical replication in general, and we don't have a magical solution for this, it is challenging for us as well, is recovering from catastrophic node loss with minimal downtime for all, especially in a cluster with 3 or more systems. And you need to basically make sure you don't duplicate any transactions. You're going to make sure you don't miss any transactions, and you have to be able to spin up full replacement nodes kind of auto-magically and smoothly. And so there's some things about logical replication that make some of these things a bit challenging. So we're working through those and working to make this so that we've at least got things that work and overcome those challenges and do it as smoothly as possible. For thinking through what these challenges are, think of a situation where there's 3 nodes, 1, 2, and 3, and node 2 goes out to lunch and is never coming back. But node 3 had played some of its transactions to node 2 and a different set of those transactions to node 1. So when that goes away, like node 3 or node 2 in that scenario they came up with goes away, and yet node 1 and node 3 don't quite agree with each other yet. And if node 2 didn't die, they would catch up to each other and they would be eventually and very quickly consistent. But if node 2 goes away and never comes back, you got to make sure that you reconcile the fact that that what you do with those transactions that made it to one of the surviving systems but not the other. So that to me is kind of a pretty good summary of what the challenge is there. So PGEdge platform is our open source stuff. So we aim to open source everything that runs on your server, such that we want you to use our cloud solutions and our fancy UI and our built-in management and monitoring. A lot of the things I'll talk about for our cloud solution, but you can run in production without us. You can hire us, and then if we don't do a good job, you can take it over yourself and do it without us. So you kind of force us to be a well-behaved vendor and earn your business every year. PGEdge Cloud is the thing that's really come out right now in private beta, right? Fully managed database as a service, handles provisioning a global cluster, including we're obviously working for it across clouds, but handles provisioning a global cluster and making sure that it's got all the right security and auditability in place so that you can kind of do all of that, because it's kind of hard to set up, frankly, a global cluster like that, and then it's even harder to prove that it's still running and auditable and still secure, and that as you put your most precious data out closer to the edge and you've got more copies of it, becomes more important than ever to make sure you're doing security and monitoring well. And I'll show you a screen capture or two of that without getting too commercial. So we start with AWS. We're very quickly supporting Azure, and then we're going to do GCP. But right out of the gate, because we are, don't laugh at me, because we are community licensed right out of the gate, you're always going to be able to also do it on-prem. And people like to do that. You like to be able to just run the whole solution on your laptop on a local cluster. I like to do that. Others like to do that. And for some use cases, we have customers that's like, yeah, I want 1 node in AWS, 1 in GCP, and 1 in my own old data center that I'm never going to quite completely turn off, but I use a lot less of it now than I used to. So key value propositions for our product and even for the platform: low latency, ultra high availability, and data residency. We talked about those, right? We just had those 3, but they had, no, wait, go back. Yeah, so you're right, I did talk about that stuff. This is just sort of a high-level architecture diagram. We have our node and cluster controllers. Those are CLIs that are all open source community licensed. We have our Spock extension, which is open source community licensed. We can run on 14, but I'm not doing right now, so pretend that doesn't say V14 right there. We're certainly in the beta period concentrating on V15. But in our if-defs in the code, you can kind of run on 14. But anyway, the product, so Spock is a regular extension. We say standard Postgres engine. And truth is, if you want to have that that feature of the delta avoid columns there, the conflict avoidance, you do need to have our little patch applied, but it will work without that. And as I said, our plan is to try to do as much as possible, as little as possible as we can here, and try to come up with, if we do come up with changes that we'd like to see there, we want to minimize them, make them generic, and work with the community to see if it doesn't make sense to put them in. So that's our plan, and we're going to stick to it, even if the community gives us a hard time. But I'm sure they won't. So this is the PGEdge org site. I cut out a little bit of stuff, but the way, and this is our platform, right? So this is our open source stuff. This is how you get to the platform. So you go in, if anybody's used like Brew on their Mac to do stuff like that, you do a little Python script that puts in our node controller, and then from there, it works the same whether you're on an Ubuntu kind of distribution, or you're on OS X, or you're on an enterprise Linux distribution, right? So it's basically gives you a sort of a control environment, so all the things work the same, and you can play around with it on your Mac the same way as you can run it in production, pretty much. The core components of what we do, so Spock right now, we're focusing on using it in PG-15. We are on our 21st iteration of 3.0, so we typically are incrementing that about once every week to 10 days as we're doing it. This is our multi-active for the Edge. Get it, the Edge, PGEdge. See, anyway, it's not that funny. But anyway, our node controller is our node and cluster controller, which I'm going to show for a second. I put Profiler up there because Jan's the author of that, so I thought that was pretty cool. We're also doing these extensions, especially these three across that top row, are important to us because when we say close to the edge, we want to make sure that for developers who call themselves modern developers, they're really JavaScript developers, and they want a REST API to the database. So we think that the Postgres extension does a nice job of that, and by default, our Edge product implements that on the different nodes, but you can certainly uncheck that checkbox and not do that. Same thing with PG Bouncer, and for our robust solution for our cloud offering, we use PG Backrest, slightly modified version of PG Backrest, but to do our backups and restores and streaming to S3 or cloud storage, et cetera. A neat one that some people are a little afraid of it. I personally like it. So if you don't like it, you don't have to use it. You don't have to install it. But this PG curl extension, which, think about in a cloud environment, all these edge providers have a sort of a cache database that's sort of an automatic cache. But what most other, in fact, I'm told that no other database products do this. It's like, what you really kind of need to do is, if they're caching a particular table, like if that table changes, you just need a REST API, wherever that shoots out, and tells them you really should refresh your cache because we changed this table that doesn't change very often. So you don't want their cache to have to read and check up on you once every minute when it only changes once every month. But you really don't want it to take a day to switch when they changed it that 1 month. So being able to do like a trigger and asynchronously just kind of pinging out to somewhere such that if their cache is up, you're just telling them you should refresh. So I think that's kind of cool for the edge kind of stuff that we're doing. PGEdge.com is the sponsor of pgedge.org, so I had them put a little banner thing there, but forget about that. That's commercial. So our CLI, which is kind of my little baby, is written in Python, comes automatically. So remember that first download, you're downloading node control, and it's really only significantly about 100K. So it downloads in a fraction of a second, frankly, even on pretty much the slowest network you can do these days. So from here, you have a series of different commands. You have your update manager commands, your system control commands, your Spock commands, which is what I'm showing here, and then you have your cluster control commands, right? Because remember, this node control stuff gives you a common way of doing stuff in a CLI that works across all the different Linux environments and all the different, well, the different OSX environments as well. So this is sort of the generated doc, but it's the typical stuff for a CLI where you can just say node control Spock help, it'll show you this, or you can say node control Spock, you know, node create, and it'll show you exactly what the parameters are there and what it is. So it's kind of standard CLI stuff. I'm a CLI kind of person, so I think you always have to start with something like this when you're doing something like what we're trying to do. The key, actually back up for a second. The key here is with, another key is that pgLogical has an API that is really a set of stored procedures. And you can still use that in Spock. So if you've got a whole bunch of scripts that are already done for pgLogical, or you prefer not to use a CLI, you want to do all your stuff in pgSQL and bash scripts, and you don't want to use this, you are still free to use, because underneath the covers, these CLIs, they kind of make it easier to call those stored procedures if you're really just trying to script it and you want to pass stuff on the command line for the simple parameters, and you want to get the result back either in human readable form and or JSON. So if you, especially once you hit here down, there's about 25 of the APIs. We're showing you the 12 most common ones that you need to get going. Yes, thank you. Thank you. So our cluster controller, part of node control. This should say node. See what says node control Spock there? That should say node control cluster. But anyhow, what the cluster controller does is let you, for testing, a lot of times if you just wanted to test and play around this, and this works on your Mac laptop or as I said, most any flavor of Linux, you can do a create local and say, I want to create 3 local nodes fully configured with Spock, and they're doing active-active replication between them. So you would say node control, cluster, create local, and then the name of it, you know, CL1, and say I want there to be 3 nodes. And by default, when you do a cluster like that, it starts on like 6432, and it would check that 6432, 6433, 6434 are open ports, and then it creates 3 different versions locally. So this, if you think about what this is able to do, the idea here is to create a local cluster for you to learn and play on, and not worry that there's no security in that cluster because it's completely local on your machine, right? You don't have to spread it out across the world and worry about security when you're playing. So the idea is that our node control cluster controller will let you create a local cluster, but then there's a JSON format, a pretty simple JSON format, where if you want to create your own nodes and create your own local remote clusters, as long as you give us the information we have the security information to be able to control those machines, then you can run commands and do different things on the different machines. So running an individual command, a node control command, let's say you want to install PostgreSQL on all 3 nodes, you would say, you know, the name of the cluster, run it on all the nodes, and then whatever the command was, install PostgreSQL. So that's pretty standard stuff. So it lets you create a local one, or you can, these other commands, if you manually created a remote cluster, you can just validate that that the JSON configuration is readable by us, and then you can control a remote cluster even if you didn't use our fancy SAS to create it. The last one is something that we're working on that's kind of cool, is because we know about the clusters, when you're doing logical replication, a lot of people want to know, how the hell do you really know those two systems are really still in sync? So we try to do something that's kind of cool here. There's some efficient algorithms going on in the background that we'll probably do some more improvement on, but for diffing a table. So if you have a particular table that's in 2 different nodes, you just got to give us the cluster, the table name, and tell it what 2 nodes you care about if there's more than 2 nodes in the cluster, and it will do the comparisons for you, show you what the differences are, and it can do those comparisons in what is sometimes referred to as a live compare mode. So let's say it's going to compare the two tables, and there's a million rows, and it comes up with 100 of them are different. It can know, you can set it by default to go in and rerun it on just those 100 rows and see if those were different because the replication was actually going on in these nodes, right? And then after it runs through that second time, if there are still differences, you can actually, because there was a bug in Jan's software and we weren't in production yet, whatever, however the differences happened, like you had shut them down and you're trying to join it. But this gives you a way to know that the system's working, and if it wasn't set up with active replication or whatever, if there were differences, this gives you a way to repair them. Not that there will be any possibility of problems like that. Doc. Examples, PGEdge deployment. So this is if you go to our booth, this is what our product looks like, our SaaS product, right? Lets you pick which nodes you want, lets you tell it to create a cluster. It'll automatically do the management and monitoring and show you something kind of Jetson looking that can show you what the latency is on the lines and what kind of data and whether there's traffic going on. You've also got a mode to, when you create the cluster, you can kind of see what's there. It's kind of simpler version of AWS. This I snuck in because I knew I was going to ask Katie to run the slides. So this slide is kind of this is our primary monitoring thing, right? So you can see like how many resolutions actually happened, and you can click on that and actually see what they were and see the diffs, so you can see if you're happy with how it did it auto-magically. You can see the status of the nodes and whether they're running and stuff. If you're wondering what is that graph, it's like I'm not sure either, but you can ask Katie what that one is. We're probably going to make that a little more meaningful in the very near future. PGEdge security in general. Remember, when you do the local cluster or when you do the other things, you can use it completely open source and you control your own security or not. Maybe you're using it all within your own firewall, so your protection is that nobody can get inside your firewall. Whatever you want to do, so you can. From my perspective, when we run with the cloud stuff, we do a bring your own account, so that you're really running in your own account. But we can still get in there and manage that. If you want to talk about that in the booth, I can kind of talk to you about that a little bit. But we automatically set up your global network the way you would want it set up, using the best practices of the various cloud providers. It's quite secure. It's done in an audible way. Curtis comes from a high security background, so he beats me up pretty well if I try to do anything that is unwise. 1 minute for production, go. Ask him any questions if you don't like it. Okay, so we still have questions. I've been pressured to finish 5 minutes early by the gentleman in the front row. That was last right wins, so I finished 4 minutes early. Who has questions? All right, be gentle with me. What's your question, sir? Yes. Yes, that's exactly right. Because it's very inefficient if you've got a shitload of columns, and you've got to do the old values for all of them. So it is like selectively doing replica identity, so that you typically only do the old and new values for the primary key, as well as this column. So if you have a small row, and you are doing replica identity without a primary key, you can do most of that without it. So you are right. It should. You'd have to ask Jan specifically whether we've coded it so it works, but it should, right? So it is the same thing. It is the old value and the new value. But we have to know. I know that we haven't tested that, but I also know that it should theoretically work. Mhm. It does not work, but I say it should, but Jan says it actually doesn't. Yeah. Okay. That's kind of what I thought, right? So it's like, it's a great question. We do want to make it so that, that patch hopefully will get accepted by the community for PG16, but also hopefully that you can run Spock and get all of the features without that core one in a way that you said, as an example, without having to apply the patch. Anybody else? Bruce? Nothing from Bruce. How about you? Philip? Okay. I think that's it. Thank you very much, and visit us in the booth, and ask us whatever you like. All right. Thank you. Ciao, ciao.